water quality early warning system for rural communities. Guided by Chaitrama, Assistant Professor Department of AMM, and our speaker coordinator Akshatama Shilpama. These are my team members Chinmay, Nikhil, and Nandan. These are the contents into our Review-1. In introduction, safe drinking water is challenge contamination or disease. By drinking contamination water, we can have a pattern of some diseases. By radiation testing, it is slow and reactive. We use AI and IoT enable real-time monitoring and early warning systems. Our system uses sensors like pH, turbidity, and temperature to dashboard alerts to improve the public health. We use pH for water consuming level to analysis and turbidity for analyzing the water contamination.
Madam, guide
Turbidity is used to measure the water salinity and salty and microorganisms included and temperature with dashboard, and these are included to the dashboards are to improve the public health. This is safe drinking is a challenging because drinking water contamination causes diseases for humans like in rural areas. Traditional testing is slow and reactive. By using the traditional method for water testing, it is difficult because we are taking water samples from the rural areas, and for testing we go to the district levels, so it is very time. So we are using AI plus IoT to enable real-time monitoring. For real-time monitoring, we use AI and also an IoT. Our system uses sensor data, pH, turbidity, and temperature with dashboard and others to improve the public health. We are using pH for measuring the water, if the water is consumed or not, and turbidity is used to measure the salinity and the microorganisms which percent is included in the water, and temperature on water and dashboard and alerts to improve the public health. This is our problem statement. Safe drinking water is a challenge in rural areas. As I know, tell about, for rural areas it is difficult because the lack of our people are not ever much knowledge about water contamination, so we are giving them, and contamination cause diseases like diarrhea, typhoid. So we overcome this challenge using this problem statement. And radiation testing is, as I told, taking samples water from the rural areas and going to the district level to test that. It is a very long process, so we use AI and IoT to test the water level, and system to predict the contamination issues to time alerts. If the water contains any issues, it is not safe drinking for safe, so we use this system. The next will continue by
here is the objectives of our problem statement. Here is the objectives of our problem statement. Monitor water quality. It means it continuously track parameters like pH, solubility, and temperature in rural water sources. And in predict contamination risk. It uses ML models to identify potential water contamination early and issue earlier warnings and alerts communities and authorities before unsafe water is consumed. In support decision making, it provide actionable insights to improve water safety management in rural areas. Here is the literature review of our problem statement. In year 2023, the author worked on utilized deep learning techniques to predict the ammonia nitrogen levels in rivers and enhancing earlier warning capabilities. In 2023, he developed a solar powered portable IoT system using LoRaWAN and to monitor water quality in rural regions. In 2024, Gen 8L proposed a low-cost monitoring system integrating AI, IoT, and most matters for materials for rural real system water quality monitoring. In 2025, OLXL reviewed IoT and TNML application for real-time water quality monitoring in developing regions. Next, my friend,
coming to methodology, index process, data collection, data machine learning method, models and predicting and early warming, data collection in that pH and purity temperature, data pre-processing, cleaning and normalization, future selection and labeling, machine learning models are random forest, logistic regression and k-nearest neighbor, prediction and early warming, predict the contamination and risk over safety result. Requirement: hardware and software. In hardware, pH, durability, temperature sensor, microcontroller, ordinary, Raspberry Pi, ESP32. Ordinary. Communication models: Wi-Fi, GSM, LoRa. Power supply: battery or solar. Computer server for ML and dashboard. Software: languages Python, libraries Pandas and NumPy. Idea tools: Arduino,
myself, I am going to explain the work plan of this project. Here we completed this is our phase 1. Here we have the project planning and the requirement analysis. What are the planning and what are the requirement we needed for this phase? First one is the defining objective and the scope of the project. What are the objective we needed and what is the scope of the project well defined in this phase. Identifying the hardware and software requirements. For the project, for every project there will be a hardware and the software process needed. In our project, hardware and software are both are needed. For literature survey and research, we have studied the literature survey from the 2023 and 24 and 25 literature survey. As our friend has suggested, studied existing research paper. As we have studied the research papers and collected information on relevant sensors, ML algorithms and deployment systems. From the research or the literature survey, we have go through what are they have used on the ML models and the sensors and development strategies, what they have used, and we have recognized it. And the data collection preparation, what are the data we needed for the preparation. Selected sensor types, pH, turbidity, temperature. We need the pH, turbidity and the temperature. Turbidity is nothing but the sensor, and the temperature what we in which temperature the water will be clean. And the plant development location rural communities. And we need for rural communities it is very critical, and we must have a plan for that, how the design must be taken. And the premier system design, designing architecture for data collection, ML prediction, alert system, and created initial methodology workflow diagram. We have to create the workflow diagram, how the process will take from starting to end. And in the future, in future work, we have implementation of develop the sensor and integrated with ML system. We have to develop the sensor and integrate it with deploy sensor and integrate with ML system. Develop a dashboard or alert interface. We must give the alert system whether the water is containing some diarrhea and dengue or diseases like. We have to give the alerts for the rural communities. And the testing and validation. Test model with real-time and historical data. Fine-tune for accuracy. For every project, the accuracy is a very important thing. If you have 100% accuracy, the project will have 100% of process performance. And final development, real-time water quality alerts, visualize trend for decision making. It is very important visualize trend for rural areas. It is very critical to take the decision whether the water is good or bad. From our project, it is very easy to take the decision for them whether water is good or bad, and improve rural water safety. And this is the conclusion where from this review 1 or the phase 1, We have defined the objectives and the requirement and the literatures and the workflow along with the system design. The data source and pre-processing approach were defined and effective model trainings. And these are the references where we have taken our phase 1 reviews.
What are the traditional methods? Anila, traditional methods ಅಂತ ಯಾವ ತರ ಇರ್ಬೋದು traditional?
ಟ್ರೆಡಿಷನಲ್ ಮೆಥಡ್ನ ವಾಟರ್ ಸಪ್ಲೈಸ್ನ ರೂರಲ್ ಏರಿಯಾಸ್ನ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡು ಡಿಸ್ಟಿಕ್ ಲ್ಯಾಬ್ ಫಾರ್ಮಲ್ಲಿ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡೋದು